My name is Nathaniel, and today we're going to talk a little bit about GraphQL. Hopefully I'll convince you that GraphQL is awesome and amazing. I mean, there's still use cases for REST. I'm not going to say GraphQL is always better than REST, but hopefully you'll come out of this knowing more about GraphQL. And I don't know, maybe for your next project, you'll consider using GraphQL as some sort of API or as something to power your front end. And also, we're going to do a little bit of like workshop-y stuff, not a ton, but I think it's usually pretty handy to get like a little bit of hands-on experience with what we're talking about. So really all you need is a computer, and I assume you have a computer if you're watching this, and then also a GitHub account. As long as you have those things, you're totally fine. We should be good.
Everyone should have a GitHub account as they've been using it for the fellowship, so it should be pretty straightforward.
Perfect. So in this talk, I'm going to cover REST first, just to sort of set the stage. And I think when we talk about GraphQL, we like to compare it to REST. So I do want to make sure that we're all on the same sort of stage. We all understand REST. So we'll cover RESTful services and REST APIs. And then we'll dig right into what is GraphQL. Look at the anatomy of a GraphQL query, what makes a GraphQL query, and we'll start to build some experience writing GraphQL queries. We'll talk about some other stuff, connections, mutations, like designing APIs, stuff like that. We'll see how much time we get. I haven't done this particular talk before, so this could be the type of thing that we get through in like 30 minutes, or it could be the type of thing that takes 3 hours to get through. We'll see. We'll get as far as we can. So really quick, just a little bit about me. My name is Nathaniel. This is me and one of my cats. This is Angie. I have 2 cats. I live in Ottawa. I currently work at Shopify, just newly joined, and before I was working at GitHub. And I love GraphQL. At GitHub, I spent about a year on like the API fundamentals team. We worked on sort of designing, not really designing APIs per se, but more we designed the best practices and built tooling for other teams to build APIs for the features. So I've had a decent bit of exposure to GraphQL. I'm a huge fan. And today I'm going to share all of that wonderful stuff with all of you. But first, before we get to GraphQL, I do have 2 cats. This is my other cat. Her name's Fergie. Here she's having breakfast with me. And if you stay around until the end of the presentation, I have, I think, 3 or 4 more cat pictures at the end, in case you're interested. So APIs. Oh, are these slides available for us to follow along with? Yes, if you want, I can definitely do that. Give me one moment. Someone just asked in chat if they can get the slides. How do I do this? Anyone with the link can view, and I'll drop them there. So you should be able to see the slides now. Let's see. Just gonna set this up. Okay, cool. No worries. So we'll talk a little bit about APIs to start, REST APIs. So what is an API? API stands for Application Programming Interface. And the way that I like to think about it, an API is just a computer-friendly interface to data. We have interfaces to data that are friendly to humans, like a graphical user interface. This is what you see when you look at a website, or you're using a desktop app, or you're using your phone. Typically, you're looking at a graphical interface. We have styling, we have design, we have positioning, we have images, we have like different fonts, all things that people really like. And it helps people sort of absorb information and process information. But computers are different than us, and computers don't really share the same appreciation for art as humans. Computers just want the data. So when we're talking about an API meant for computers, it's really just the data, it's text. An API is simply some interface where a computer can go and take in data about a thing. This is an example of the GitHub API, where I can query for information about my GitHub user. And here, it doesn't look like the GitHub profile page. It's all the info that's on the profile page, but it's just like JSON, it's just text. So not useful for me, but very useful for computers. Now, moving on to REST APIs, there's not all APIs are REST APIs for one. REST, which stands for Representational State Transfer, really just defines some constraints and rules that a web service should follow, which is kind of like confusing. But if a web service follows these rules, we call it RESTful. And if an API follows these rules, we call it a REST API. So that's all REST really is. We have rules. If we follow the rules, we are RESTful. Now, there's a lot of rules, and some of them are a little bit confusing. But we're going to go through some of the more simple ones and some of the more like, I guess, useful and like actual ones that you'll see, which will help you sort of design a web service or an API as like RESTful, or what we would call RESTful. So in a REST API or in a RESTful service, we use the URL to describe the resource we want. That's one of the rules. So this, the top, where we use like /user/1, that's good because we're using the URL to refer to the thing that we want. Using the query parameters is bad. That's not RESTful. And describing the user in the post body or the request headers, that's bad. That's not RESTful. I mean, you don't have to do REST, but if you're trying to be RESTful, this is bad. In REST, only resources and collections exist. This is really more of like a, I guess, just like a way of thinking about things. When you're looking at REST, everything is a resource or a collection of resources. And you can figure that out from the URL. So here we're looking at user1. This is a resource where the user is the resource, and /users would be a collection of users. Those are the two things that we can talk about in REST. 99% of the time. There's exceptions to everything. This is also interesting. D12 isn't a number, and it's not prefaced by like a collections thing, but it is still like, you don't have to follow that pattern in REST. This is still a resource, as long as like you have to define those practices somewhere. You have to define like how your URLs are formatted, but this is a resource. And then the last rule that I'm going to talk about is how the HTTP method describes the action in REST. And depending on whether you're acting on a resource or a collection, your HTTP request will do a different thing. So sending GET requests is generally about fetching data, just like in HTTP in general. It's always about fetching data. When we're sending a GET request to a resource URL, we're asking for detailed information about a single resource. When we send a GET request to a collection URL, we're asking for less information about every resource in the collection. Sometimes that information will only be the resource URL for each of the resources in the collection. It's really up to the API for how they want to define that. So this is information about every resource. I say each with an asterisk because if I have 10 million users, this is definitely not going to return 10 million users. So we do have pagination when we're querying for collections, and that's a thing. That's fine. Post to a collection creates a new resource in the collection. I've ignored resource posting to a resource because it's extremely uncommon and not really worth talking about. We can put to replace a resource. We can patch to update a resource, and then delete destroys things. So we can delete a resource or a collection where we're going to either destroy a resource or a collection. So we have APIs. We can query for resources. We can query for collections. That's mainly the thing that I'm trying to get across here. That's like the restrictions of a REST API. We're querying for things or collections of things. And we can do things too, like we can update or destroy things or collections of things. Just some examples here. Here, like I'm fetching on my user/followers, this would be a collection. So I'd be getting a list of the followers. This would be posting to /repos would create a repository under my account. Patch to a specific repository would update that repository. And then getting to /repos would fetch a list of repositories. This one is interesting. I'm just getting the root. Whoops. This is sort of up to interpretation. It depends on the API or the web service. You can, like I said, you have to define everything as a resource or a collection of resources. This would probably be a resource, which would be like your dashboard or something like that. But the main thing that I'm trying to say here is that this is RESTful, even though it doesn't look like it's RESTful. So that's REST, just like a very, very quick summary of REST. Now, where does REST fail is the main thing that I want to talk about. So no matter what information you need from a REST payload, REST will always give you the entire resource payload. This is unnecessary work and computation. I can show you that if I can move this zoom doohickey, put that over here. So I'm just going to go to the GitHub API, and here I've fetched for information about my user. If I was just looking for my email, there's no option to just fetch my email. I have to fetch an entire resource, and that's it. That's the only thing I can do. So here, github.com, the server, has computed all these fields for me. They put a lot of work into making sure it's all right. And I'm going to discard all of it. I don't need any of it except the one field. So that's wasteful. That's a limitation of REST. Not much we can do there. If you need detailed information about every resource in a collection, you're going to have to make many queries. You can query for a collection, but like I said, it's only going to give you very limited info about every resource in the collection. So typically what ends up happening when you need detailed information about every resource in a collection, like maybe I want to get, I don't know, the email of all of my friends per se, what I have to do is send a request to the collection to get the URLs of all of those users, and then send another request for every user that I need. That's called an N+1. The 1 is referring to my request for the collection. And then I have to make N more HTTP queries to get all that data I need. That's slow. It's going to take a while. If I need to fetch 100 users, I'm making 100 HTTP requests. There's a lot of overhead as well to making 100 HTTP requests. Every time I do that, we have to send another request over the internet. It takes time to get there. The server has to authenticate me. It has to validate my credentials and all that. All that has to happen before it can even send me the thing that I want. So this is a big problem. It's gonna take a lot of time if we need to fetch this type of information with REST. And then just if you need to access a lot of resources, you have to make a lot of queries. That's another fundamental issue with REST. There's not much else to say there. If you need a lot of data, you have to make a lot of queries. There's no way to batch things together. There's no way to request like compound resources or specify that you want more than one resource. Every resource you want is an HTTP query, and they add up and they're slow, especially if you're querying for a server that's far away. Like if I'm querying a server on the West Coast, that's 80 milliseconds of ping to get there. Multiply that by, say, 20 requests, that's almost 2 seconds just in fetching data, which is a waste. It's a ton of time. I just see a question here. I think if there was a way we could send a body with the GET request, we could have avoided requesting the entire payload. What is your opinion on this? Do you mean using the body of the GET request to specify which fields we want? Right. I'm going to assume that's what you're talking about. We could also use, exactly, okay. Yeah, so we could do that. There's other ways that we can do that without a body of a GET thing. Yeah, like the query string, headers, I guess, if you wanted to. Like there's various ways to send information. The query string is probably the best one. So that is an option. REST APIs typically don't work like that. I'm not 100% sure if that's allowed by REST rules, but it's uncommon, and that's not a thing that happens, unfortunately. But that type of solution could probably solve that problem in particular if it was implemented. Yeah. So that's a good question. It's a really good question. So we'll move on then from REST, unless anyone else has any other questions. Yeah, no worries. Okay. So GraphQL to the rescue. Let's talk a little bit about GraphQL. This is kind of what GraphQL looks like. There's lots of sort of look at here. On the left, I have a query, and on the right, I have a response. My query is specifying the data that I want, and on the right is the response that I get from the server. You'll see here, we're not looking at URLs anymore. I'm not using the URL to specify the data I want. I'm actually writing a query, which I guess you can compare it to like sending a SQL query to a SQL server. It's like a string that I would put together. There's more complexity here. Here, like I have this user which has arguments. So I'm specifying that I want a specific user. I'm specifying that I want specific fields on the user. I would assume that there's more fields on user besides name and URL. And I'm only telling the server that I want these two fields. And that's all I'm getting. And one other cool thing to look at here is that the model of the query matches the model and the shape of the response data. So the way that I type my query tells me how my response is going to look. Exactly. This is exactly the structure that my response JSON will look like. So that's pretty cool. Let's dig into it a little bit more and figure out what we're looking at here. I think, oh, I skipped a slide. I was wondering where that slide was. Okay. So a GraphQL query describes exactly what data is needed and can ask for lots of different pieces of data in one request. Jumping back here, we're specifying exactly the data we want, and we can fetch, like here I fetched user, but after this closing curly brace here, I think I can get a laser pointer. There we go. After this closing curly brace, I could ask for another field. You can ask for many different things. The GraphQL server responds with exactly the data that was asked for in JSON format. Queries are always sent as post requests, which is interesting. So we're deviating from REST here. Even though my query wasn't mutating data, it wasn't creating a record, all queries are sent as post requests. The query string is sent in the post body to a single GraphQL endpoint. So we're throwing away the idea of URLs as well. We only have one URL, which is the GraphQL endpoint. And we send our query as post body to the GraphQL endpoint. And one other thing, the GraphQL API has a strongly typed schema that defines exactly what data is available. Sort of like if you've used a strongly typed language before, your IDE can tell you what methods are available on different things. We can do something similar with GraphQL. And let's jump into the Explorer to take a look. I will send a link to this in chat in case you want to play along, but I will will also be doing sort of like exercise type stuff afterwards. So that's there. You might need to authenticate. I'll go through how to do that in just a minute. So while we're here, I'm going to explain the anatomy of what we're looking at. This is called the GraphQL Explorer. This is on github.com. So we're querying for github.com data using the GitHub GraphQL API. On the left here is our query. And when I press play, it will run the query. And then the response will show in this little panel here, and I can run it just to do that. So I ran my query, and here's the response data. Pretty simple. We have variables down here, but we're not going to play with variables right now, so I'm just going to put that away. And then on the right, I have the documentation, which is actually the strongly typed GraphQL schema that defines exactly what data is available on every type. Now, with other strongly typed languages, we have the concept of types and different fields, like you would call them methods in programming, but these, we call them fields. Fields can return types. Now, so we have the query, and the query begins on the query root. So if we're trying to see what we can type here, and we're trying to figure out what we can query for, we start at the root. That's where the GraphQL query starts. And now this documentation tells me all the things I can query for from the root. We have code of conduct to look up a code of conduct, licenses, categories. We can look up an organization. Let's find the viewer, which I'm doing in my query here. So viewer returns the currently authenticated user, and it tells me that it returns a user object. So what I'm doing here, I'm querying for viewer, and then the curly braces mean on the returned viewer object, I'm going to select more fields on the viewer object. In GraphQL, you can't request for just like an object. You have to request all the way down until you have scalars everywhere. So what I'm trying to say is this isn't valid because this is a complex type, and we're not allowed to just return complex types as leaves because like if we're looking at this, remember I said that the query and the response shape have to look the same. So what exactly would it put as the value for this key? It's a complex type. It can't really do that. So we have to break a complex type down into scalars, into like scalar selections. And what I'd done in this one was just use login. So I can click on the user type and look for login in our schema here. Login is a string. The username used to log in. That's good. That's a scalar type. That's like a very basic type. And now my query is fine and it works. So all of that works, and I can use this schema over here to find the data I'm looking for. Now I can make as complex of a query as I want. I can fetch exactly the data I need to render. Say I'm trying to render a web page, or I'm looking for really complex data. I can expand this query basically as big as I want. I can ask for really whatever data I'm looking for. The GitHub API does have a limit. I think you can fetch 5,000 pieces of data in one query, maybe more. But you can fetch a lot. Maybe it's 500,000. I can't remember. Anyways, it's a lot of data. So let's see. In the Explorer, handy little shortcut, you can do Control-I, and you get this drop down, which will show you all the things that you can select on a user. Maybe I want to know when I was created. Maybe I want to know my avatar URL, and what else? My name would be cool. And then we'll run that. And there we go. I got my new fields that I was asking for. I can also go back down to the root and fetch another root node. I can make as many sort of like selections on the root as I want. Maybe I want to request a repository. Now, this field is interesting because let's just go back to our query and let's look up repository. Here's a repository. Look up a given, make this bigger just in case. look up a given repository by the owner and repository name. We see here that this is a field that has arguments. Let me get one bigger. So this is a field that has arguments. So in our query, we have to pass arguments. That looks like this. We have parentheses, and then it's going to need a name. I'm going to search for Linux, and we need an owner. And that is owned by Torvalds. And that will return the repository. I've passed in arguments. Just from looking at the schema, I can figure out which arguments are required. And then remember, this is a complex type. It returns a repository. So I'm going to have to open this up and make selections on the repository. Maybe I just want the name with owner is fine. And I can run my query. And there we are. I have my response. So what we're seeing here is essentially a solution to all the problems that we saw with REST. We're able to fetch exactly the data we need. We're able to fetch as much data as we need. We have many different resources. We can make as complex of a query as we want. The only other thing that we haven't covered yet is collections. How do we do something with collections? Say, let's see what else we can do on a repository. It's probably a good, okay, forks. Now, I'm going to get to, let's scroll down to, I want a repository, and then repository has forks here. This returns a connection, and I'm going to talk about connections in just a minute, but you're just gonna have to bear with me while I get through this. So we're going to have to give how many forks we want. That's required in this case. So let's say I want 10 forks. Now, this returns a repository connection, and we can look at the type here. These are the different things that it returns on the connection. These aren't the repositories. This is some complex intermediary type, and we'll talk about why this exists in just a moment. But to get to the repositories, all I have to do is select the nodes. And now I'm on the repositories. And I can do name with owner here. Now this is kind of interesting because I've selected 10 forks, and then I've said I want the nodes, which gives the repositories, and then the name with owner. And if I run that, it gives me the name with owner for all 10. It handles arrays very cleanly. If you select an array and then you make selections on the array, it'll make that selection on every element of the array. GraphQL handles that very cleanly. Okay, so we've covered collections and arrays. We haven't talked about connections. That's going to come in just a second. The way I've explained this has been sort of, let's just dive into it. So I just want to check, is anyone confused about anything that we've covered up until now? If you could send a message in the Zoom chat, that would be great. We have selections, we have arguments, and then we have these connections. Ricky has been enlightened. That's good to hear. Can GraphQL only be used with organizations that provide it? So the organization does have to, I'm assuming you mean like the company or the service, they do have to put up the GraphQL API for you to query it. If they don't provide an API, then you can't query. You can't query like a REST API with GraphQL. Is there any way to fetch everything without manually mentioning all keys? No, there isn't. There's no way to do that. And that's sort of a practice that I think the people who designed GraphQL want you to stray away from. GraphQL is interesting because the schemas tend to evolve over time. It's very easy for people designing these schemas to just add new things to these types, and it doesn't break any existing queries. So these APIs can be developed very fluently, very easily. And what that would mean is if there was a way to say, like, I want everything, maybe like asterisk was the way, your request would keep on fetching more data as the type got bigger. And ideally, like when you're fetching the data, you have an idea of exactly what data you need. So it's good to just explicitly mention exactly what data you need. We try not to fetch all data in GraphQL. That's a good question, though. Okay. It looks like that's it for questions, but if you do have anything else, just drop a question in the chat and I'll be sure to answer it. At this point, I think it would be cool for people to actually start playing around with GraphQL. It's one thing to watch me typing GraphQL queries, but it's another to actually play around with the Explorer, see how it works, get a feel for the documentation, get a feel for Command I or Control I. So what we're gonna do, the first thing, we're all gonna have to get access to this Explorer. So I sent a link in the chat, but I will send it again just so it's at the bottom. So this is the GitHub GraphQL Explorer. When you navigate there, you'll probably be asked to OAuth. Remember that this API is using your real GitHub data. Everything you fetch here is real GitHub data. Nothing we've covered so far can delete or destroy data, so don't worry about that. But more just remember that the data you're querying is real GitHub data, just in case, I don't know. If you're sharing like queries, for example, or if you're sharing responses, it might include private repo data or something like that. So if you go there, you should be able to OAuth. Let me know if anyone runs into issues with that. I think it's pretty straightforward, but I haven't done it in a while. Let me just sign in with GitHub in the corner. Oh, I've already OAuth'd, so I don't have to do it. Okay. I'm going to assume that everyone was successful, but if not, just let me know. So we have some exercises here, and I'll copy them into chat just in case you don't want to keep this window open. But let's take, we'll say 5 minutes, maybe a little bit more if people need time, to write these 3 GraphQL queries. We're going to try to find the number of public repositories that you have, the number of followers that Torvalds has, and then the created at date of Torvald's 10 most recent pull requests. One other thing, though, that I do want to cover, because I didn't show how to get the number of things, and I guess that would probably be helpful. Repositories. So with these connections, remember I showed you can do like first and whatever. If you're just looking for the count, you just open it up and do total count. And then there we go. That'll work. Now, we're looking for repositories, but we're not looking for this. This is how to look up repositories. What we're really looking for is the repositories on our user. So we can use the viewer that we saw earlier to get our current user, to get our authenticated user. And then on that, we have repositories, which is probably what we want. Okay, so I have viewer, we want repositories, and we're just looking for the count. So I can do total count like that, and that works. And I have the number of repositories. The number of followers that Torvalds has. This is Linus Torvalds, the Linux guy. So first up, we need to find Linus, which find his user. And we can use the user field for that to look up a user by their login. User Torvalds. And now what did we want? The number of followers. Followers is a thing. Total count. He has an insane number of followers, 120,000. And then I think the other one was a little bit harder. The created at date of Torvald's 10 most recent PRs. So we're still on Torvald's. Now we want pull requests. And then do we say the 10 most recent? So we can use last for this to fetch the last elements in the list. So I'll fetch the last 10. And then remember, we just use nodes. We'll explain connections in a minute. And then created at to fetch the created at date on the pull request objects. And there we are. We have all the data that we want. Okay, so let's move on then and talk about connections. What the heck are connections? Really, what we're looking at here when we're looking at connections, I'm just looking for a list, of things, but this doesn't return an array. It returns a lot more than an array. Let's work backwards and try to figure out why that is. You'll also notice if we look at what other fields are available on this connection object, there's edges, nodes, page info, total count. Type name is a GraphQL thing. That's not important. Also edges though, and then edges have a cursor and node. So let's figure out what all that means, because that's ridiculous and confusing. Okay, so we want to return a list of things. Very simple. Say I have friends. I want to see my friends. I want to fetch my friends. So why don't we design this sort of schema? Now, a quick note on the schema, the sort of notation that we're looking at here. We have a field called friends. It returns an array of users. And the exclamation point here means that friends cannot be null. In GraphQL, empty array is not null. So empty array is still allowed, but we're saying null, like we should never be returning null from a list of things because we have empty array. There's no reason to return null. So we have friends, it returns an array of users, and that array will never be null. That seems straightforward. That would work. I would have my list of friends. It would be way more simple than what we're looking at right now in the GitHub API. But what if I have thousands of friends? I don't have thousands of friends, but maybe some people do. We need pagination to make this work. So what about something like this? Where we have like first and last, and we can have other pagination arguments. Like I want the first people after this many, whatever, and that returns a list of users. That's an improvement. Now we have pagination, and that resolves our issue with returning thousands and thousands of users and slowing down everything and sending ginormous payloads. But what if we want information about the collection itself, like total count, for example? With this model, we have no way of fetching the number of friends in total. Friends only gives us a list of users. And when I'm making selections on my list of users, I'm making selections on user objects. They don't have information about how many friends I have. So what we could do is have another field on the user object that says like friends count. And then for every list, we would have two fields. We would have like friends and friends count. But that's not optimal. There also might be other information about a collection that would be interesting. Here we're only looking at total counts, but what if we had more? What we really want is a place to store this information that talks about a collection of items. Information that pertains to a collection is what we're looking for. So that is where the connection type comes from to start. Now here we have this friend connection that gets returned from my field here. And this includes our users, but also information about the collection. So here we are. We have, we would do friends, pass in the pagination information, it returns a connection, and then on the connection, we can fetch our nodes, which gives us the users, and we can fetch total count. Amazing. But if you remember, go back here. We have this edges thing, which has other stuff. And that edges exist on every connection. And actually, something that's interesting that I didn't tell you earlier is that nodes on the connection object doesn't exist in most APIs. This is a shorthand for edges. Whoops, let me move that. Edges node created at. Nodes is just a shorthand for this. So this is actually the way that our connection is organized. Now, why is it organized like that is the next thing that we need to figure out. What if we want to store information about the relationship between objects? Let's look at our schema here and try to figure out how we might be able to do that. We can't put the data, so just to clarify here, say I want to know when I became friends with a certain person. All of my friends, that information doesn't pertain to a user. That doesn't belong on the user object. When I became friends with Matt, that doesn't make sense. It also doesn't make sense for that to be on his user object, because that's information about his user. It also doesn't make sense to live on the connection, because that's talking about the collection as a whole. It doesn't make sense to have information about one connection, or not connection is a bad word to use, but one friendship, really. That information wouldn't live here. What we need is a type that describes a relationship, and we can put information on that type. And so we have the really complex schema that you see with connections in the GitHub GraphQL API. And this is how every list of things is in every GraphQL API. So I would suggest not saying, oh, that's weird, but I'm never going to use the GitHub API. I'm going to write my own GraphQL API. If you want to use GraphQL at some point, you have to sort of wrap your head around this. It's just the way it is. So we have a field that returns a connection. That connection has edges. And this is that type that I was talking about, that type that describes a connection between two different types. It's the edge. If you look at a graph, it's the edge between two nodes. That's why it's called an edge. Whoops. That is where we would store information about a friendship. And then we would have, we could have a friends at on the edge, and that we can use that to tell when two friends became friends. And then on that edge, we have the user as well. So that solves all the problems that we had. It's pretty complex. Does anyone have any questions about why connections are the way they are? They're a little bit iffy, a little bit confusing for sure, especially if it's the first time that you're sort of taking a look at this sort of stuff. No questions yet, so that's good. If you have questions, just leave them in chat. Could you go over these again? Yeah. So I'll go over this. We have the field friends that returns the connection object. And this object, the purpose of it is to store information about the entire collection of things, really. So for example, total count. That's information that pertains to my entire collection. It doesn't pertain to one friendship, really. It pertains to a collection of friends. So that is information that would live on the connection. And then on the connection, we have a list of edges. And on those edges is where we would store information that links two users together. So let me go to the Explorer actually really quick, and I'll show what this might look like. So for pull requests, what sort of connection might there be between, let's do something else instead. I don't know, followers, edges. Is there, we don't have anything useful here really for an example. So yeah, on this edge is sort of where the information that links to people would be. And that, yeah, that would be in here alongside node. And the edge is where information that describes the relationship goes. That's specifically what the edge is for. And then the node also hangs off of that. And remember, the node always describes like the thing that you're looking for, really. So here I'm looking for friends, it's a user, so my node would be user. And someone actually just brought up a really good point. Why on this friend edge is nodes a list of users? And that's a great question. And the answer is that I made a typo. And that is actually supposed to be node is a user. Like that. Really good question. I missed that. So on an edge, we only have one user, of course. It's a link between one user and one user. There's only one user on an edge. Is anyone else still confused about anything there? Yep, no worries. So this is the type of thing where really just playing around with it can help a lot. The cool thing about the GitHub API, I'm pretty sure it's the largest public GraphQL API out there. So if you're looking to sort of just get a hang of how GraphQL works, I would really just recommend pulling up the GraphQL Explorer and taking a look at everything, making queries and whatnot, and just sort of getting a feel for how everything works. Query for complex data. It's really the best way to start to understand how these concepts piece together. And I did mention earlier that I wasn't sure how much time I would have. And it looks like I didn't have enough time to cover most of what I was going to cover, but I did get through most of it actually.
You can continue if you have the time yourself. We don't have any other sessions like back to back. So if you want to like run over like 15 minutes or so, be my guest. Okay.
Unfortunately, I do have things to get to, but I'll take like 2 minutes just to like speed through a couple other points. We didn't talk about mutations. Everything we've covered so far is about querying data, but we can also mutate data in GraphQL. Now, just to show really quickly what that looks like, and I'm not going to dive into it. If you're interested in learning more, I would suggest looking up how to do mutations in GraphQL. But what we can do, so at the beginning, I did have query. If I change that to a mutation, now I'm telling GraphQL that I want to make a mutation. And a mutation is just a query that changes data. Now, we were working on the query root. That was the things that I could fetch for in this space here. But now I'm on a mutation. I'm going to be selecting things off of the mutation root, which you can see on the right side here. And now this is a list of different things that I can run as mutations. An easy one, create repository. It lets you create a repository. You pass in the right inputs and it will create a repository. It works kind of like a field with arguments. I don't have time to run through all that, so I would recommend looking that up in your free time if you're interested. Powering your front end with GraphQL, all I really wanted to say about that is that the typical way to use GraphQL in a web application is to have the back end focus on making data available, and then the front end focuses on fetching data it needs via the GraphQL API. In a typical web application, you have the back end worrying about like figuring out what data a specific view needs and passing the correct data down to the view. That whole responsibility is eliminated when you use GraphQL, because all you have to do as the backend is provide an API. You don't have to provide different APIs for different views because the view can craft its own query and fetch exactly what data it needs. So GraphQL is commonly used to split the sort of concerns there and to simplify your backend. And that is it. And just a couple of cat pictures. This is Fergie. This is Angie. And this is Angie and Fergie. And like I said before, the link to the slideshow is in in the chat if you want to see more cat pictures or if you want to look at this information later.
Awesome. Thanks, Nathaniel. Really do appreciate it.
Yeah, no worries, no worries.